Hello everybody, and welcome to exercise 4 on page 12 of the workbook. Okay, and they're asking us to integrate the function x to the fifth times e to the x cubed in this case. Okay, and the form of this function is kind of complicated, and so this would be a difficult problem to do if we tried to attack it immediately using integration by parts. One reason for that is the fact that we've got this x cubed in our power. And so one strategy that we could use in this problem is to first do an ordinary u substitution just to simplify the form of this integral first, and then see what we can do with that. That's going to be our strategy here. All right, so because we're going to be using integration by parts later on in the problem, I'm going to use the variable w for the substitution here, just so we can keep all of our letters straight from each other. All right, so ordinary substitution, we're going to let w equal x cubed. And if we do that, then the derivative of that w, dw, would look like 3x squared dx. Okay, if we take that equation and get the dx by itself, okay, we can divide both sides by 3x squared, and dx is dw over 3x squared. So we're just doing an ordinary substitution here using the letter w. Let's see what our integral looks like if we rewrite it using those pieces. Okay, so we're starting from x to the fifth. We let x cubed be w, so I'm going to write w for that. And then we can see from our work that dx is equal to dw over 3x squared. Okay, can we do any cancellation here? Well, notice that the x squared cancels into the x to the fifth and leaves us with an x cubed left over. That's one piece of cancellation that we can do. Okay, but there's still some x's left. Okay, we've still got an x cubed in the problem, and to complete this substitution, we need to get rid of that x cubed. So here's the going fishing part. Can we go fishing for an x cubed? Well, notice we don't have to fish too far. W is equal to x cubed, so we can replace that x cubed with w. Okay, one last thing that you might notice that we can do here is there's an over 3 in the denominator that we can pull out as a 1/3. Let's do that as well. Okay, so notice that the integral that we have now looks quite a bit better than the one that we started with. The one that we started with had an x to the fifth and an x cubed in it. We've just got w's in this integral. The powers aren't nearly as big. Okay, and so what we're going to do now to finish this is we're going to use integration by parts to do the resulting integral in terms of w that we have here. All right, now we did a problem similar to this. It just happened to involve the variable x instead of w. The idea is the same though. We can make w equal to u and e to the w dw equal to our dv. Okay, I'm going to write those choices down below here. Okay, after we make those choices, we need to figure out what the du and the v are. So if we take the derivative of w, we're going to get 1, just the same way that if you took the derivative of x, you would get 1. So 1 times dw. And then if dv is e to the w dw, take an antiderivative of e to the w, and you get e to the w again. Okay? And so, continuing on, this integral that we have, if we write out the integration by parts formula, we've got a 1/3 in front, and then integration by parts formula tells us uv, that's going to be w times e to the w, minus the integral of v du, that's e to the w times dw. Okay? And let's see. To continue the problem, we need to integrate e to the w, but we know an antiderivative of e to the w is just itself. So let's see, we'll get 1/3 w e to the w minus e to the w. This is an indefinite integral, so we'll put a plus c on the end. Okay, and we have found an antiderivative, but we started with an integral at the beginning that had x as its variable, and so our last step here should be to convert back to x's. All right. Let's see, what is w equal to? We kind of have to sort through our work and find it. There's a lot written down here, but notice up here, w is x cubed, so let's just substitute x cubed for all our w's. Okay, so every w is going to become an x cubed. Okay, and we could either take that as our final answer, or another alternative would be just to multiply that 1/3 through the quantity, and we could also write our answer like this. Okay, and so notice this is yet another example that illustrates that some integrals you will need to combine various techniques together. We actually used a substitution and integration by parts in this problem.